Hello and welcome once again to the Akash Byju's JEE channel. My name is Atiullah and we are live with JEE Advanced 2022. So if you want to crack this exam, this is the place to be. This is the place where we are giving you all the tools, arms and arsenal to crack this exam and all important boost in the last few days that you have. Alright, are you guys excited? I am very excited to bring you photoelectric effect, because this is a part of modern physics, a very important chapter because it is a very scoring chapter, right guys? So guys coming in already, Chiranjeevi, hello, good evening. Pulkit, a very good evening Pulkit. Vaishnu, good evening. Geeta Shri Nivas, good evening. Love Kush, good evening. Pala Nivel, please teach in English. So Pala Nivel, I'll try to keep it in both languages. All right. Shri Charan is also here. Good evening. Gurmail Singh, very good evening guys. Very good evening. कैसा लग रहा है? सबसे पहले you guys tell me how are you feeling? JEE Advance is just a few days away. How are you feeling about it? All right, are you feeling excited? Are you feeling nervous? Are you feeling afraid? Are you feeling, what are you feeling? I want to know from you. What are you guys feeling? All right, I want to know from you. Yes, 11 days to go. How is the feeling? How is the Josh inside? Or are you nervous? Are you afraid of something? Nervous. All right, Gurmail Singh says he is nervous. All right, other people, what do you think? What is going on in your mind? How are you feeling? All right, JEE Advanced, the big exam. This is going to help you. This is the gate through which you can go into IITs. Okay, so some people are saying excited, some people are saying nervous. अच्छा लग रहा है but एकदम से डर लग रहा है. Cool, demotivated. All right. So I knew this already because there are going to be a lot of different emotions running through you. Okay, it's absolutely natural to have these emotions running through you. But the thing is, as I always say, that in these last moments, what you have to focus on is your strength and your temperament, right? Again, guys, your temperament is very important. So you don't need to take any stress. You don't need to think about the future. ठीक है, अपने ऊपर ये सब प्रेशर मत लो कि नहीं हुआ तो क्या होगा, नहीं हुआ तो माँ बाप बोलते हैं कि पान की दुकान पे बिठा देंगे, ये बेचना पड़ेगा, वो करना पड़ेगा. ठीक है, so all those things, all those negative emotions, all those negative thoughts जो भी आपके ऊपर आ रहे हैं या आपके अंदर जो भी जनरेट हो रहे हैं, you have to set that aside. Alright, so all those negative thoughts, you have to set that aside and you just have to focus on your performance. Alright, so all you have to do is do your best, keep a calm head, keep a cool head and just go for it. Alright, don't think about the consequences, only concentrate on your preparation and how you're going to give your best. That is it, and there's nothing else to worry about. And a little bit of nervous excitement is important, right? There's a little nervous excitement, okay? Everyone has that. Before you're going to take any big thing, you're going to do any big thing in your life, there will be a nervous excitement, okay? And that is a positive thing because that gets your adrenaline pumping, that gets your hormones pumping and you perform better, you can focus better and you are more pumped up. All right, with that said, we are going to start this session. We are going to do photoelectric effect. We are going to do some very good questions, advanced level questions, and with this I'll try to make you revise photoelectric effect in totality. All right, so are we ready to get started? All right, chalo. So before we begin, few important announcements. Okay, so you would have heard about ANTHE के बारे में सुना होगा. So if you know someone who is from class 7th to class 12th, please tell them, and you guys also please register for ANTHE and you get a lot of benefits from it. Okay, what are the benefits? You can get up to 100% scholarship. You can win an all expense paid trip to NASA. You can get cash rewards and also become an all India rank holder. Alright, so do register for it. Link is in the description. And also guys, you're getting a free 14 days trial for the Akash Byju's app, which has top notch content. Do check it out. A lot of interesting stuff over there. And if you like what we are doing, if you think that we are adding any value to your preparation, then do give us some encouragement, give us a like, subscribe and share it with your friends, spread the word around. That is going to mean a lot to us. Alright guys, with that said, we are all set to begin this session. Are you excited? Are you all pumped up to solve all these questions? So you're not going to sit idle. What you're going to do is you are going to solve everything with me. साथ में solve करना है, copy और pen लेके बैठिए, okay? So if you guys are excited, if you guys are ready, give me a yes, give me a thumbs up, show some excitement, show some cheerfulness. All right, okay, because all of this that we are going is going to be very, very helpful. All right, Shivani is here. O is saying I'm not late today. That's good. We are just beginning. So let's get started. Chalo, let's get started. ठीक है, this is the first question for you. What is the question? Figure shows a block A of mass m and the dimension of the block is given, right? Can you see the dimension of the block? The dimension of the block is A cross B cross H. So what you see here is that A is over here and H is over here, okay? The face you are seeing is A and H, which means the dimension B is going into the plane of the screen, okay? So that is clear. ये समझ में आ गया? All right. अब आगे क्या हो रहा है? It is placed on a horizontal smooth surface attached to a side wall by a light string. Diagram में समझ में आ रहा है? If sunlight of intensity I falls on it at an angle theta to horizontal and surfaces of block are perfectly black. Perfectly black का मतलब क्या होता है? It is going to be absolutely absorbing. 100% सब कुछ ये absorb कर लेगा. So what do we need to find out? We need to find out the tension in the connecting string. Pulkit is saying radiation pressure का question है. Yes, absolutely radiation pressure का question है. So guys, I want to know from you how do we proceed with this question? Okay. What is the key catch in this question? What is the key concept in this question? What is the hurdle that has to be crossed in order to solve this question? First, I want to know from you. What is the concept? Okay, so you tell me what is the concept that needs to be dealt over here, and then we are going to proceed. Okay, Pulkit is saying radiation pressure, photon pressure. You are absolutely right. You're absolutely right. So because photons have momentum, they can transfer momentum, and hence they can apply force, and hence they can apply pressure. So that is absolutely right. But how do we solve this question? Okay, so before we begin solving this question, I'm going to revise radiation pressure for you in a very quick time. Okay, ज़्यादा टाइम नहीं लूँगा, फटाफट आपको एक फॉर्मूला बताऊंगा, उस एक फॉर्मूले से आप सारा कुछ डिराइव कर सकते हो, आप हर स्पेशल केस को डील कर सकते हो. Okay, so what is that? The radiation pressure, what we need to remember is that the radiation pressure is given by I by C cos square theta into 1 plus R. Okay, what is I? I is the intensity, C is the speed of light, theta is the angle of incident, and what is R? R is the fraction that gets reflected. ठीक है, अगर 100% लाइट गिर रही है तो उसमें से कितनी परसेंट लाइट रिफ्लेक्ट हो जाती है? What fraction of the light gets reflected? That tells us, R tells us that. ठीक है, पुलकित बोल रहा है मुझे भी बस टॉपिक का नाम याद है, फॉर्मूला वगैरह भूल गया. कोई बात नहीं पुलकित, इस सेशन में आपको सब कुछ याद आ जाएगा और ऐसा याद आ जाएगा कि आप फिर भूलोगे नहीं. ओके, ट्रस्ट मी, आई एम गोइंग टू make sure that you don't forget it. All right, so what is the radiation pressure? I by C cos square theta 1 plus R. Now we are going to talk about special cases. Okay, what is special case number 1? The special case number 1 is that normal incidence हो रहा है. ठीक है, light is falling perpendicularly. Now if light is falling perpendicularly, then in that case there would be two cases. If light is falling perpendicularly, what does that mean? If light is falling perpendicularly, it means that theta will be equal to 0 degree. Is that correct? ठीक है, तो अब what will it reduce to? It will reduce to I by C 1 plus R. Okay, now there are two more cases. First case, perfectly absorbing. If it is perfectly absorbing, then R will be equal to what? R will become 0. Is that correct? If it is perfectly absorbing, then no light is getting reflected. The value of R is going to be what? The value of R is going to be 0. So what are we going to get the radiation pressure as? We're going to get the radiation pressure as I by C. Is that correct? Okay. So what is this case? Normal incidence and it is perfectly absorbing. So here it is going to become I by C. Okay. Now if it is perfectly reflecting, another special case, in that case what will happen? R will be equal to 1, correct? Whatever light is falling, that entire light is getting reflected. So in that case, R will be equal to 1. So in this case, the radiation pressure is going to become 2I divided by C. Is that correct? Plain and simple. Okay? We don't need to remember much. All we need to remember is this. Okay? All right. Next, what is the special case? If it is falling at an angle. Okay? If it is falling at an angle, then what will happen? Theta is going to be the angle of incidence. And when theta is angle of incidence, again there will be two cases. What is the first case? When it is perfectly absorbing. When it is perfectly absorbing, R will be equal to what? R will be equal to 0. So this is going to become I upon C cos square theta. And what is the other case? The other case is then when it is completely reflecting, R is going to become 1 and this is going to be 2I upon C cos square theta. Guys, are you here with me? Okay, if you understood this, give me a yes, give me a thumbs up if you understood this. So what did we learn here? All you have to do is, you have to remember what is radiation pressure. And if you remember what is radiation pressure, then by substituting the value of theta and substituting the value of R, you are going to get the desired formula. Is that correct? तो 4 की जगह अपने को क्या करना है? सिर्फ एक फॉर्मूला याद रखना है. गुड, आई लाइक दोस थम्स अप्स. परफेक्ट, ग्रेट. चलो, लेकिन इसमें एक नुआंस भी है. इसमें एक थोड़ा सा कैच भी है. What will be the direction of force? Okay, what are we talking about here? We are talking about the force exerted. So direction of force को भी अपने को थोड़ा ध्यान में रखना पड़ेगा. Okay, now when we are talking about perfectly reflecting surface, when we are talking about perfectly reflecting surface, उस केस में क्या होगा? ठीक है, उस केस में ये होगा कि light is falling like this. Okay, now in case of normal incidence कोई चक्कर ही नहीं है. ठीक है, in case of normal incidence there is no problem at all. ठीक है, because what will happen in normal incidence? When light is falling like this, light is falling like this. Okay, what will be the direction of force exerted? The direction of force exerted would be this. ठीक है, and let's say the area is this. Now how do we define pressure? याद करो, how do we define pressure? We define pressure as F perpendicular divided by the area. Very important, guys. Very, very important, guys. Okay, the pressure, the radiation pressure is, or in fact any pressure. How do we define pressure? That's the basic definition of pressure, that is F perpendicular divided by the area. Now in this case, the force is already perpendicular, so we don't need to take any component. So all said and done. Okay, everything cool, no worries. Okay, so if we know the radiation pressure, we'll simply multiply by area and then we'll get this force. Okay, so this case you are not going to face any problem. Okay, now let's talk about a case when the radiation is falling at an angle. Now when the radiation is falling at an angle, in this case what we have considered is this is perfectly reflecting. If this is perfectly reflecting, then it is going to get reflected like this. The change in momentum would be in what direction? It will be in the upward direction. So the force exerted would again be perpendicular to the surface. Is that correct? The force exerted would again be perpendicular to the surface. So in this case also, we don't have to take any component. So what will be the force exerted? The force exerted will simply become pressure into area. Is this correct? Okay, when there is normal incidence, force is equal to pressure into area. When it is incidence at an angle, but it is perfectly reflecting, in that case also, the force is going to be pressure into area. Is that correct? Are you guys here with me? Give me a yes. If this is absolutely clear, give me a yes. Chalo. Now we are going to talk about perfectly absorbing case. Perfectly absorbing case. Then perfectly absorbing case, what is going to happen? ठीक है, the angle of incidence here I am saying is theta. In this case, what is going to happen? In this case, the force would be exerted in this direction because the change in momentum is going to be in this direction. Do you agree? Okay, it had some momentum in this direction and then after getting absorbed, its momentum became zero. So what is the direction of change in momentum? The direction is in change in momentum would be along the direction in which light is traveling. Is that correct? ठीक है? Is this clear? So force कैसा होगा? Force will be at an angle. ठीक है? Force कैसा लगेगा? Force ऐसा टेढ़ा लगेगा. Force would be at an angle. Is that correct, guys? Absolutely clear? Okay. Now how do we define pressure? We define pressure as F perpendicular divided by area. Okay, how do we define pressure? F perpendicular divided by area. What is F perpendicular over here? F perpendicular over here is F cos theta. Can you see that? F perpendicular is F cos theta. So what can we say? That the pressure, okay, the radiation pressure. What will be the radiation pressure in this case? The radiation pressure in this case would be I by C cos square theta. Do you agree? ठीक है, I by C cos square theta. Now this is equal to F perpendicular. What is F perpendicular? F perpendicular is F cos theta, and then we have to divide by area. Let's say the area is A over here. So from here what will happen? 1 cos theta and 1 cos theta will get cancelled, and in this case the force exerted will become how much? It is going to become I by C into A cos theta. Is that correct? So this case is a little bit different. The force exerted will become I by C cos theta, and what will be the direction of the force? The direction of force would be in the direction of the incident light. Can you see this? Is this clear? Absolutely clear. इसमें कोई confusion है, कोई problem है, कोई दिक्कत है, परेशानी है तो बताओ मुझे. Is this absolutely clear? Now यहाँ पे we'll take a shortcut. ठीक है, यहाँ पे we'll remember something. What is this A cos theta? What is this A cos theta? Now if I take the projection of this area perpendicular to the direction of light, ठीक है, so you can work this out. This becomes A cos theta. फिर से सुनो क्या मैं बोल रहा हूं कि अगर ये जो एरिया है इसका प्रोजेक्शन हम ले लें, ठीक है, इसका कंपोनेंट ले लें या इसका प्रोजेक्शन ले लें perpendicular to the direction of light, that will become A cos theta. With simple calculation we can see that. Okay, so what we can say that the force exerted would be I by C into area of projection. So whenever you have a case where it is perfectly absorbing, तो टेंशन लेना ही नहीं है. आ रही बात समझ में? Whenever you have a case where light is getting perfectly absorbed, in that case and especially in that case, reflecting वाले केस में वो हम नहीं कर सकते हैं. आ रही बात समझ में? Not for reflecting case. We are only talking about perfectly absorbing case. In that case, the force will simply become I by C into area of projection. That is it. बस यही करना है. I by C into area of projection. और area of projection क्या है? Area of projection है when you project the area, when you take the component of the area perpendicular to the direction of light. That's it. Clear guys? Any problem? Reflecting, अंश पूछ रहा है reflecting m force is reflecting में force is equal to 0. नहीं, reflecting में force 0 क्यों हो जाएगा? Reflecting का तो केस हमने ऑलरेडी देख लिया. Reflecting का केस क्या होगा? Simply ये हो जाएगा, या तो ऐसा होगा या तो ऐसा होगा. रिफ्लेक्टिंग के केस में चाहे वो सीधा गिर रहा है चाहे वो टेढ़ा गिर रहा है, रिफ्लेक्टिंग के केस में फोर्स क्या हो जाएगा? द रेडिएशन प्रेशर मल्टीप्लाइड बाय द एरिया. तो रिफ्लेक्टिंग के केस में तो कोई प्रॉब्लम है ही नहीं. ठीक है, सिर्फ थोड़ा बहुत कैच किस में है? थोड़ा बहुत कैच है जब परफेक्टली एब्जॉर्बिंग है, वो भी जब किसी एंगल पे गिर रहा है. ओके, तो अगर किसी एंगल पे गिर रहा है तो हमने फोर्स वर्कआउट कर लिया. बट आई क्या समझ में बात? सिंप्लीफाइड लैंग्वेज में बात ये समझ में आई कि आई बाई सी लेना है और एरिया ऑफ प्रोजेक्शन से मल्टीप्लाई कर देना है. एरिया ऑफ प्रोजेक्शन क्या है? कंपोनेंट ऑफ द एरिया और प्रोजेक्शन ऑफ द एरिया विच इज परपेंडिकुलर टू द डायरेक्शन ऑफ लाइट. बस इतना आप याद रखोगे तो परफेक्टली एब्जॉर्बिंग वाला जो केस है वो बहुत आसानी से सॉल्व हो जाएगा. ऑलराइट, नाउ विद दिस अंडरस्टूड, ठीक है, आपका रेडिएशन प्रेशर का मैंने पूरा रिवीजन करा दिया 5 मिनट में. अब सुनो, अब इस केस को सॉल्व करते हैं, इस क्वेश्चन को सॉल्व करते हैं. ठीक है, नाउ दिस रेडिएशन इज फॉलिंग ऑन दिस सरफेस एज वेल एज दिस surface. Do you agree? This radiation is falling on both the surfaces. ठीक है। इफ रेडिएशन इज फॉलिंग ऑन बोथ द सर्फेसेस, तो दोनों सर्फेस के ऊपर अपने को क्या निकालना पड़ेगा, फोर्स निकालना पड़ेगा, ठीक है। लेकिन ये केस कैसा है, ये जो ऑब्जेक्ट है ये परफेक्टली ब्लैक है। अगर परफेक्टली ब्लैक है मतलब कौन सा केस है, इट इज परफेक्टली एब्जॉर्बिंग, और परफेक्टली एब्जॉर्बिंग का रिजल्ट तो अभी देखा, तो वो अप्लाई कर देते हैं। चलो अप्लाई करते हैं। तो आई लाइट यहां से ऐसे, क्या एंगल है, ये हॉरिजॉन्टल से एंगल हमें दिया हुआ है थीटा, ठीक है। यानी कि फोर्स किस डायरेक्शन में लगेगा, फोर्स इसी डायरेक्शन में लगेगा, है कि नहीं। फोर्स किस डायरेक्शन में लगेगा, फोर्स इसी डायरेक्शन में लगेगा, ओके। बट ये जो फोर्स है, चलो इस फोर्स को हम क्या कह लेते हैं, F1 कह लेते हैं। इस फोर्स को हम क्या कह लेते हैं, F1 कह लेते हैं, ठीक है। तो ये F1 किसके बराबर हो जाएगा, ये F1 हो जाएगा इक्वल टू I बाई सी इंटू एरिया ऑफ प्रोजेक्शन। अब एरिया ऑफ प्रोजेक्शन निकालना है, ठीक है। सो व्हाट इज द एंगल ऑफ इंसिडेंस ओवर हियर, द एंगल ऑफ इंसिडेंस इज थीटा ओवर हियर। कैन यू सी दैट on this surface? What are we talking about? We are talking only about this surface, ये वाला surface. We are only talking about this surface. So what is the angle of incidence? The angle of incidence is theta. अब इसका प्रोजेक्शन हम ऐसा परपेंडिकुलर लेंगे तो इस एरिया ऑफ प्रोजेक्शन का वैल्यू कितना आ जाएगा, ठीक है। इस एरिया ऑफ प्रोजेक्शन का वैल्यू कितना आ जाएगा, इसका एरिया कितना है, इसका एरिया कितना है, हाइट है h, ठीक है। एरिया कितना है, हाइट है h, और अंदर कितना जा रहा है, अंदर जा रहा है b, यानी इसका एरिया क्या हो जाएगा, b इंटू एच। ये बात समझ में आ रही है, हाइट है h और अंदर कितना जा रहा है, अंदर जा रहा है b, यानी एरिया कितना हो गया, b इंटू एच। एंगल ऑफ इंसिडेंस कितना है, थीटा, यानी ये कितना हो जाएगा, BH cos थीटा। डन, आई बात समझ में, एग्जैक्टली। अंश यू आर एब्सोल्युटली राइट, टॉक्सिक यू आर एब्सोल्युटली राइट, ठीक है, बिल्कुल सही बात बोल रहे हो। तो इस सरफेस पे जो फोर्स लगेगा वो कितना लगेगा, I बाई सी इंटू BH cos थीटा। अब सिमिलरली इस सरफेस को भी देख लें क्या। अब लाइट यहां पे गिर रही है ऐसे, ठीक है, लाइट गिर रही है कैसे, लाइट गिर रही है ऐसे, यानी इसके कारण भी जो फोर्स लगेगा वो इसी डायरेक्शन में लगेगा, अलोंग द डायरेक्शन ऑफ लाइट। इज दैट करेक्ट, ओके। अब यहां पे एंगल ऑफ इंसिडेंस कितना हो जाएगा, हॉरिजॉन्टल से एंगल थीटा है तो वर्टिकल से एंगल कितना हो जाएगा, वर्टिकल से एंगल 90 माइनस थीटा हो जाएगा। इज दैट करेक्ट, ओके। सो व्हाट विल बी से, F2 कितना हो जाएगा, F2 हो जाएगा I बाई सी मल्टीप्लाइड बाई, अब किस सरफेस की बात कर रहे हैं, अब हम इस सरफेस की बात कर रहे हैं। इज दैट करेक्ट। अब इस सरफेस का एरिया क्या होगा, बताओ इस सरफेस का एरिया क्या होगा, ये कितना है, ये है A और अंदर कितना जा रहा है, B जा रहा है, ठीक है। तो एरिया हो गया AB, लेकिन इसका प्रोजेक्शन लेंगे तो ये क्या हो जाएगा, ये हो जाएगा AB। अब क्या होगा, cos 90 माइनस थीटा, बिकॉज ये एंगल ऑफ इंसिडेंस कितना है, 90 माइनस थीटा, यानी ये हो जाएगा cos 90 माइनस थीटा, यानी कि ये क्या बन जाएगा, ये बन जाएगा I बाई सी AB इंटू साइन थीटा, ठीक है। अब आप देख लो F1 भी किस डायरेक्शन में है, इन द डायरेक्शन ऑफ लाइट। F2 भी किस डायरेक्शन में है, F2 भी है इन द डायरेक्शन ऑफ लाइट, यानी कि नेट फोर्स कितना आ गया, नेट फोर्स आ गया F1 प्लस F2, यानी कि ये कितना हो जाएगा, ये हो जाएगा I बाई सी, कॉमन क्या आएगा, कॉमन आएगा B, एंड देन अंदर कितना हो जाएगा, अंदर हो जाएगा H cos थीटा प्लस A sin थीटा, H cos थीटा प्लस A sin थीटा। इज दिस करेक्ट गाइस, एनी प्रॉब्लम अप टिल हियर। तो रेडिएशन प्रेशर का जो खेल था वो खेल हो गया खत्म, अब बचा क्या, आप तो सिंपली इक्विलिब्रियम देखना है। इज दैट करेक्ट, ओके। नाउ ऑल वी हैव टू लुक एट इज वी हैव टू लुक एट द इक्विलिब्रियम। सो नाउ लेट्स लुक एट द इक्विलिब्रियम, ठीक है। तो लाइट ऐसे आई और फोर्स लगा इस डायरेक्शन में, ठीक है। तो ये एंगल है थीटा हमारे पास, तो ये एंगल भी क्या है हमारे पास, थीटा, ठीक है। अब बेसिकली क्या करना है, फोर्स को परपेंडिकुलर और हॉरिजॉन्टल डायरेक्शन में हमको रिजॉल्व कर लेना है। तो इधर क्या आएगा, इधर आएगा F cos थीटा, इधर क्या आएगा, इधर आएगा F sin थीटा, ये हो जाएगा टेंशन और बाकी mg होगा और बाकी नॉर्मल होगा। लेकिन हमें सिर्फ क्या निकालना है, हमें निकालना है टेंशन, ओके। और टेंशन बहुत क्लियरली इस डायग्राम से समझ में आ रहा है दैट द टेंशन विल बी इक्वल टू F cos थीटा, ठीक है। F का वैल्यू कितना निकाला था हमने निकाला था I B अपॉन C, फिर हमारे पास था H cos थीटा प्लस A sin थीटा, और इसको किससे मल्टीप्लाई कर देना है, इसको मल्टीप्लाई कर देना है cos थीटा से, और हमारा आंसर आ गया। इज दिस करेक्ट? इज दिस क्लियर? एनी प्रॉब्लम, एनी कंफ्यूजन, एनी डिलेमा, कोई भी तकलीफ है इस क्वेश्चन को समझने में? ठीक है, सात्विक पूछ रहा है सर मॉक टेस्ट में 35-40% ही आ रहा है, अब इंक्रीज ही नहीं हो रहा है। ऑलराइट गाइस, सो इफ यू हैव एनी क्वेश्चंस रिलेटेड टू योर प्रिपरेशन, इन द एंड 5-10 minutes आई एम गोइंग टू कीप फॉर योर questions, specifically for your questions regarding preparation। मैं 5-10 मिनट रखूंगा, आपकी जो भी डाउट है मैं I'll try to resolve that। ठीक है, तो एंड में करेंगे वो चीज। ठीक है, सो सात्विक यू बी विद अस, यू गो थ्रू ऑल दीज क्वेश्चंस, ऑल दिस सेशन, एंड इन द एंड आई एम गोइंग टू आंसर ऑल योर डाउट्स। ऑलराइट, चलो बढ़िया। तो यहां से आपका रेडिएशन प्रेशर का रिविजन भी हो गया और हमने ये सॉल्व भी कर लिया। ठीक है, इंपॉर्टेंट थिंग to remember is that for perfectly absorbing, the force is I by C into area of projection। ठीक है, बहुत जगह आता है, बहुत सारी जगह आता है। ठीक है, तो ये अगर हम याद रखेंगे तो क्वेश्चन हम जल्दी सॉल्व कर पाएंगे। बट रेडिएशन प्रेशर निकालना हर केस में मैंने आपको रिवाइज करा दिया। इज दैट करेक्ट? ऑलराइट, परफेक्ट गाइस, सो इफ दैट इज क्लियर देन वी आर गोइंग टू मूव टू द नेक्स्ट प्रॉब्लम। व्हाट इज द नेक्स्ट प्रॉब्लम? In an experiment on photoelectric effect, a light of wavelength 4000 angstrom is incident on a cesium plate at a rate of 5 watt. The potential of collector plate is made sufficiently positive so that the current in discharging tube obtains its saturation value. If on average, out of every 10 to the power 6 photons, one photoelectron is ejected, find the photocurrent in the discharge tube. चलो, क्वेश्चन क्लियर है? क्वेश्चन बिल्कुल क्लियर है? अगर क्वेश्चन क्लियर है तो मेरे को बताइए कि की कैच क्या है इस क्वेश्चन में। व्हाट इज द की कॉन्सेप्ट इन्वॉल्व इन द क्वेश्चन? राइट गाइस, क्विकली टेल मी व्हाट इज द की catch or what is the key concept in this question? What do you think? How should we proceed with this question? Okay, what's the crux of this question? फंडा क्या है इस क्वेश्चन का? फटाफट बताओ मुझे। I want to know from you before I start solving. I need to know from you कि आपको समझ में आ रहा है कि नहीं आ रहा है। ठीक है, मैं समझाऊंगा तो समझ में आ जाएगा, बट क्वेश्चन देख के are you able to get the hints so that you can solve this question? अंश बोल रहा है समझ नहीं आया सवाल। अंश, सवाल बहुत सिंपल सा है। सीजियम प्लेट है हमारे पास, ठीक है, सीजियम प्लेट है हमारे पास, इसके ऊपर रेडिएशन गिर रहा है 4000 एंगस्ट्रॉम का, ठीक है, और जो रेडिएशन का जो पावर है वो पावर कितना है? वो है 5 वॉट, यानी पर सेकेंड 5 जूल एनर्जी उस प्लेट पे गिर रही है। करेक्ट? ओके, अब क्या होगा? अब फोटो इलेक्ट्रिक इफेक्ट होगा। फोटो इलेक्ट्रिक इफेक्ट होगा, इसका मतलब क्या है? इलेक्ट्रॉन निकलेगा, फोटो इलेक्ट्रॉन निकलेगा, ठीक है। अगर फोटो इलेक्ट्रॉन निकलेगा तो हमें यह बताया गया है कि 10 टू द पावर 6 फोटोन अगर गिरेगा प्लेट पे, अगर 10 टू द पावर 6 फोटोन प्लेट पे गिरेगा तो सिर्फ एक इलेक्ट्रॉन निकलेगा। आ रही बात समझ में? ठीक है, if 10 to the power 6 photons are falling on the plate, only one electron is going to get ejected. Is that correct? So what we need to figure out here is that what will be the photocurrent in the discharge tube. Clear? Is the question clear? Now is the question clear? Okay. पुलकित बोल रहा है पहले एनर्जी निकालेंगे then number of photons. ठीक है? Okay, okay, all right. ठीक है, चलो। अब सिंपल सी बात इतनी है ना, what we need to find out here? We need to find out how many electrons are getting ejected per second. ठीक है? If we know how many electrons are getting ejected per second, we know the charge getting ejected per second. And if we know the charge per second, the charge flowing per second, then we know the current. So this question boils down to finding what is the number of electrons getting ejected per second. That is it. Is that clear? Okay, all we need to do is find out the number of electrons getting ejected per second. Chalo. So if we have to find out the number of electrons getting ejected per second, first we need to find out how many photons are falling per second. Is that correct? How many photons are falling on the plate per second? How do we figure that out? हमें पावर दिया हुआ है और हमें वेवलेंथ दिया हुआ है. ओके, नाउ गाइस, कैन आई से that the power is equal to nhc by lambda? Can I say that? Guys, tell me, do you understand this or should I explain this? The power is going to be nhc divided by lambda. What is n? N is the number of photons per second. गौरव बोल रहा है I'm late. कोई बात नहीं गौरव, this is only the second question. यहां से स्टार्ट करो, बाद में फर्स्ट क्वेश्चन देख लेना. ओके, Can I write power as nhc divided by lambda? Can I say that? ठीक है. How do I say that? फिर से चलो, if you are not able to understand this, I'll explain it to you. एक एनर्जी की एक फोटोन की एनर्जी कितनी होती है? hc by lambda. What is the energy of one photon? hc by lambda. If n photons are there per second, ठीक है, n photons per second, तो पर सेकेंड कितनी एनर्जी हो गई? nhc by lambda. Is that correct? And energy per second is what? Energy per second is power. So power is equal to nhc by lambda. तो यहां से we simply get n is equal to p lambda divided by hc. Is that correct? Okay. So this is the number of photons falling per second. Is that correct? Number of photons falling per second. But जितने photons गिर रहे हैं उतने इलेक्ट्रॉन्स निकल नहीं रहे हैं. सिर्फ 10 to the power 6 photons में एक इलेक्ट्रॉन निकला है. So can we say that the number of electrons that are going to be ejected is going to be n divided by 10 to the power 6? Is that correct? 10 to the power 6 में एक निकल रहा है. ठीक है, तो number of electrons, number of photoelectrons that are going to be ejected is going to be n divided by 10 to the power 6. So this is going to become p lambda upon hc into 10 to the power 6. यही तो निकालना था. So what have we figured out? We have figured out that the number of photoelectrons ejected per second would be this. Okay. So what will be the current? The current would be the charge per second. What will be the charge per second? The charge per second would be the electronic charge into Ne. Do you agree? Okay. So this is going to be the electronic charge. ठीक है, एक इलेक्ट्रॉन के ऊपर कितना चार्ज होता है? ई चार्ज होता है. एंड कितने इलेक्ट्रॉन पर सेकंड निकल रहे हैं? एनी इलेक्ट्रॉन्स पर सेकंड निकल रहे हैं. सो द करंट विल बी इक्वल टू व्हाट? द करंट विल बी इक्वल टू ई इनटू एन ई. इज दैट करेक्ट? ओके, सो व्हाट इज दिस गोइंग टू बिकम? दिस इज गोइंग टू बिकम पी लैम्डा ई अपॉन एच सी इंटू 10 टू द पावर 6. ठीक है, इसको कैलकुलेट करेंगे तो अपना आंसर आ जाएगा. कैलकुलेशन में भी आप थोड़ा स्मार्ट बन सकते हो. ठीक है, सो ऑलवेज गाइज व्हाट यू नीड टू डू इज substitute in the end. Okay, don't substitute in the beginning. If you substitute in the end, you will benefit from the calculation. Okay, so I'll show that to you. So this is p lambda by e. The current is p lambda e divided by hc into 10 to the power 6. What is the value of p? The value of p is 5 watt. The value of lambda is 4000 angstrom. तो ये हो जाएगा 4000 इंटू 10 टू द पावर माइनस 10 मीटर. ओके, द इलेक्ट्रॉनिक चार्ज आई एम लीविंग इट एज ई. ओके, द इलेक्ट्रॉनिक चार्ज आई एम गोइंग टू लीव इट एज ई डिवाइडेड बाय hc. hc का वैल्यू याद है? hc का वैल्यू होता है 1240 इलेक्ट्रॉन वोल्ट नैनोमीटर. इज दैट करेक्ट? एंड देन वील हैव 10 टू द पावर 6. अब फायदा यहां पे क्या हुआ कि दिस इलेक्ट्रॉन एंड दिस इलेक्ट्रॉन गेट्स कैंसल्ड. करेक्ट? इलेक्ट्रॉनिक चार्ज इंटू 1 वोल्ट क्या होता है? इलेक्ट्रॉन वोल्ट. सो यहां पे जो ई है और यहां पे इलेक्ट्रॉन वोल्ट में जो ई है वो हो गया कैंसिल. सो व्हाट आर वी लेफ्ट विद? वी आर लेफ्ट विद 5 इंटू 4000 इंटू 10 टू द पावर माइनस 10 डिवाइडेड बाई 1240. Now this is in nanometer. We need to convert into meter. So this is going to become 10 to the power minus 9 and here we have 10 to the power 6 already. Is that correct? ठीक है, तो the figure is such that क्वेश्चन इतना मुश्किल नहीं है. ठीक है, द क्वेश्चन इज नॉट दैट, मतलब कैलकुलेशन इज नॉट दैट डिफिकल्ट. अब ये कैलकुलेशन आप बहुत आराम से कर सकते हो. करेक्ट? एंड इफ यू डू दिस कैलकुलेशन द आंसर यू आर गोइंग टू गेट इज अप्रोक्सीमेटली 1.6 माइक्रो एम्पियर. ओके, द बैक स्पेस इज आस्किंग सर हाउ आई इज इक्वल टू ई एन. ठीक है, ऑल राइट. सो बैक स्पेस करंट क्या होता है? व्हाट इज करंट? करंट इज द चार्ज divided by time. Is that correct? What is current? Current is charge divided by time. Now let's say we have n electrons. Okay, we have n electrons. So what will be the charge? The charge is going to be Ne divided by T. What is n? N is total number of electrons. Okay. But what is capital N divided by T? Capital N divided by T is the number of electrons ejected per second. So that is what I am writing as small n. Small n is per second. So I becomes equal to n into E. That's it. Clear? Backspace, is that clear? If it is clear, give me a thumbs up. Guys, is this question clear? Alright, chalo. So let's look at the options. So option B is going to be the correct option. Is that correct? Alright. Yeah, it was a simple question, but we are only warming up. I wanted you to understand the relationship between power and n. ठीक है? सात्विक बोल रहा है सर वन डाउट, इतना इजी क्वेश्चन एडवांस में आते हैं. सात्विक, ट्रस्ट मी 40 to 50% ऑफ द पेपर एडवांस में आसान आता है. ठीक है, सेट मेथड पे आता है. सो इन एडवांस द ट्रिक इज अगेन to figure out and find out those easy problems and solve them. ठीक है, इतना easy question भी आता है JEE एडवांस में. You are absolutely right. चलो, but difficult भी आता है, तो preparation तो अपने को top notch रखना है. Clear? चलो, now let's look at this question. Let's see if this question is advanced level or sub-advanced level or super advanced level. Let's figure that out. Alright, chalo, let's look at the next question. Now, a filter transmits only the radiation of wavelength greater than 4400 angstrom. Radiation from hydrogen discharge tube grows through such a filter and is incident on a metal of work function 2 electron volt. Find the stopping potential which can stop photoelectrons. Is the question clear? Is the question clear? Any doubt in the question? Tell me. If there is any doubt in the question, do let me know. This is the situation. So hydrogen gas is heated. Okay, hydrogen gas is in a discharge tube. It is heated. So when it is heated, what happens? It emits radiation. Okay, it emits radiation. Now there is a filter in between. Now this filter is only going to allow radiation which is over 4400 angstrom. Okay, it will only allow radiation which is over 4400 angstrom. Okay, now after it has passed through this filter, it is going to form, it is going to fall on a metal, and this metal has a work function of 2 electron volt. So what will happen? Photoelectric effect is going to take place. Electron is going to get emitted. So we want to find out that in order to stop that photoelectric effect, I need to know what will be the stopping potential. Priyansh बोल रहा है hello sir, sorry I am late. Priyansh कोई बात नहीं, concentrate on this question. ठीक है, whatever you have missed, you can always go back and look at the video again. Live की सबसे अच्छी बात यही है, live भी हो जाता है, record भी हो जाता है, so you can always go back and watch the things that you missed out. Now guys, you tell me what is going to be our modus operandi here. How do we solve this question? What is the key concept? What is the key catch? How do we proceed with this question? Give me ideas. Suppose that I don't know how to solve the question. Okay, I am your student. And you are going to tell me how do I proceed with this question. You explain it to me. How do I solve this question? All right, सौरभ राणा बोल रहा है सर क्या मुझे JEE एडवांस के लिए रिडो सॉल्व कर लूं? सौरभ एंड में बात करते हैं. ठीक है, विल टॉक इन द एंड. सौरभ पूछ रहा है मॉडर्न फिजिक्स पर ग्रिप बनाने के लिए. सौरभ एंड में बात करेंगे ना, डोंट वरी. ठीक है, एंड में 5-10 मिनट्स आई विल कीप जस्ट टू चैट. ठीक है, विल जस्ट चैट. Don't worry about it. I'll answer all your questions. ठीक है, प्रियांश बोल रहा है फर्स्ट काइनेटिक एनर्जी निकालेंगे. ठीक है, काइनेटिक एनर्जी कैसे निकालेंगे दोस्त? काइनेटिक एनर्जी कैसे निकालेंगे? क्वेश्चन समझ में आ रहा है? क्वेश्चन में कैच क्या है ये समझ में आ रहा है कि ओनली रेडिएशन विच इज अबव 4400 एंगस्ट्रॉम, ओके, ओनली दैट इज अलाउड. अब दिस वी हैव टू अंडरस्टैंड that how does hydrogen gas emit radiation. Now hydrogen gas emits radiation because of some transition. गैस को हीट किया तो एटम हायर एनर्जी स्टेट में चला गया, हाई एनर्जी स्टेट से लोअर एनर्जी स्टेट में आया तो रेडिएशन एमिट होगा. इसका मतलब क्या है? दिस मीन्स that whatever wavelength of radiation is being emitted is corresponding to some transition. Is that clear? Whatever wavelength is getting emitted, yaad hai discrete wavelengths, whatever wavelengths are getting emitted are corresponding to some transition in the hydrogen atom. Do you agree or not? पुलकित बोल रहा है सर जितनी वर्क फंक्शन है उतना पहले टोटल एनर्जी में से सब्ट्रैक्ट कर देंगे, कंसिडरिंग वेवलेंथ 4400 मैक्स एनर्जी केस है. पुलकित सही जा रहे हो, तुम सही डायरेक्शन में जा रहे हो, बट थोड़ा उल्टा हो गया. जो एनर्जी होगी ना, एनर्जी क्या होती है? एनर्जी इज hc बाई लैम्डा. तो जो एनर्जी होती है, या मैं डेल्टा ही कह लूं, एनर्जी ऑफ ट्रांजिशन जो होती है वो होती है hc बाई लैम्डा. इसका मतलब क्या है कि लैम्डा ज्यादा होगा तो एनर्जी कम होगी, एनर्जी कम होगी तो लैम्डा ज्यादा होगा. ये बात समझ में आ रही है? ऑलराइट, चलो चलो इसको कैसे सॉल्व करें. तो सबसे पहले क्या है कि कितनी एनर्जी जा रही है, ठीक है, कितनी एनर्जी जा रही है. सो व्हाट वी नीड टू फिगर आउट इज दैट दिस 4400 एंगस्ट्रॉम, व्हाट एनर्जी डज इट करस्पॉन्ड टू. ठीक है, energy corresponding to 4400 angstrom I want to find out. Okay, so what is that going to be? That is going to be hc by lambda. Okay, so what is this? This is 1240 electron volt nanometer divided by, we have 4400 angstrom, yani ki 440 nanometer. So what is this going to give? 0 and 0 gaya, ye 411 times, ye 431 times, yani ye kitna ho jayega? 4 2s are 22, 9 आएगा तो 2.8 इलेक्ट्रॉन वोल्ट. ठीक है, अप्रोक्सीमेटली 2.8 इलेक्ट्रॉन वोल्ट. नाउ अंडरस्टैंड दिस गाइस, द एनर्जी that is passing through this filter is going to be less than 2.8 electron volt. Do you agree? ठीक है, whatever energy is passing through this 2.8 through this filter is going to be less than 2.8 electron volt. Do you agree? ठीक है, because if we increase the wavelength, the energy is going to further decrease. Correct? So the energy which is crossing through this filter, okay, the energy which is crossing through this filter is going to be less than 2.8 electron volt. Is that correct? Okay, but photoelectric effect should happen, and photoelectric effect is only going to happen if the work function is greater than 2 electron volt. Do you agree? Photoelectric effect can only happen if you have supplied the energy which is greater than 2 electron volt, which is greater than the work function. What does it mean? It means that the energy which is crossing through, the energy which is crossing through has to be, this energy which is crossing through this filter has to be between 2 and 2.8 electron volt. Is this clear? Is this concept absolutely clear? The energy which is going to cross through has to be between 2 and 2.8 electron volt. Is this correct? Now, ये एनर्जी आ कहां से रही है? ये एनर्जी आ रही है हाइड्रोजन के ट्रांजिशन से. तो अपने को क्या देखना है कि हाइड्रोजन का कौन सा ट्रांजिशन इस एनर्जी को करस्पॉन्ड करता है. आ रही है ये बात समझ में? जो भी एनर्जी आ रही है कहां से आ रही है? हाइड्रोजन एटम में कुछ ट्रांजिशन हो रहा है और उसके ट्रांजिशन से जो एनर्जी आ रही है, ठीक है, वो क्या होनी चाहिए? वो 2 और 2.8 इलेक्ट्रॉन वोल्ट के बीच में होनी चाहिए. अब आपने अगर मेरा पुराना सेशंस देखा है, इफ यू सीन माय previous sessions, I have already told you that you should remember these values. अब इसमें Rydberg formula लगाने लग जाओगे तो बहुत लंबा हो जाएगा कैलकुलेशन. You should remember this. At least 7 energy levels तक, 6 n is equal to 6 तक याद होना चाहिए. ठीक है? Okay. So यहाँ पे क्या आ रहा है? This energy has to be between 2 and 2.8 electron volt. ठीक है, the energy of transition has to be between 2 and 2.8 electron volt. So anything coming to 13.6 उसे काम नहीं चलेगा, बहुत ज्यादा हो जाएगा, रेंज से बाहर. यानी कि 3.4 तक आनी चाहिए, कहीं से 3.4 तक आनी चाहिए. अगर 1.5 से 3.4 आएगी तो कितनी हो जाएगी? 1.9 इलेक्ट्रॉन वोल्ट. इज दिस विद इन आवर रेंज? नो, दिस इज नॉट विद इन आवर रेंज. अगर 0.85 से -0.85 से -3.4 आती है तो कितना हो जाएगा? दिस इज गोइंग टू बी व्हाट? दिस इज गोइंग टू बी 2.55 इलेक्ट्रॉन वोल्ट. इज दिस विद इन आवर रेंज? यस, दिस इज विद इन आवर रेंज. यानी कि ये हो गया करेक्ट. कोई और भी हो सकता है। अगर 0.55 से आएगी 3.4 तक तो ये कितना हो जाएगा, ये कितना हो जाएगा, ये हो जाएगा 3.54 माइनस 0.55, तो 10 में से 55, ये हो जाएगा 2.85, जस्ट एक्सीड कर गया। आ रही बात समझ में, जस्ट एक्सीड कर गया, 2.85 इलेक्ट्रॉन वोल्ट आया, यानी कि ये एनर्जी भी नहीं चलेगी। यानी कि एक ही पॉसिबिलिटी है, देयर इज ओनली वन पॉसिबिलिटी। ओके, व्हाट इज दैट पॉसिबिलिटी? दैट ट्रांजिशन इज गोइंग टू हैपन फ्रॉम n इज इक्वल टू 4 to n is equal to 2, which means the photon will have an energy of 2.55 electron volt. Is that correct? तो बोर्स मॉडल का काम अब खत्म हो गया। अब सिंपली हमारे पास क्या बचा है, यहां पे 2.55 इलेक्ट्रॉन वोल्ट की एनर्जी फॉल कर रही है। इसका मतलब है कि K max कितना हो जाएगा? So what will be K max? Let me write it over here. What will be the K max? K max would be equal to the energy which is falling, hc by lambda, the energy which is falling minus phi. So this is going to be 2.55 minus 2, which is 0.55 electron volt. तो K max कितना हो जाएगा? 0.55 इलेक्ट्रॉन वोल्ट। अब इस 0.55 इलेक्ट्रॉन वोल्ट को रोकना है तो स्टॉपिंग पोटेंशियल कितना हो जाना चाहिए? द स्टॉपिंग पोटेंशियल शुड बी 0.55 वोल्ट। इज दैट करेक्ट? इज दिस क्लियर? ठीक है। सो in summary, what did we do? We saw that the energy which is passing through this filter should be between 2 and 2.8 electron volt, correct? Only then photoelectric effect is going to happen. ठीक है, so it should be between 2 and 2.8 electron volt. Now in this case we have to see that for which transition of hydrogen the energy is going to fall in this range. ठीक है, so we checked from 3 to 2, we checked, it was out of range. We checked from 4 to 2, it was within range. We checked from 5 to 2, it was out of range. So what was the only possibility? The only possibility was n is equal to 4 to n is equal to 2 transition. In that transition, how much energy is released? 2.55 electron volt of energy is released, which means how much energy is falling on the metal? 2.55 electron volt is falling on the metal. Okay, so what will be the maximum kinetic energy? The maximum kinetic energy is going to be 2.55 minus the work function. So the maximum kinetic energy is going to be 0.55 electron volt. So if maximum kinetic energy is 0.55 electron volt, what is the stopping potential? Stopping potential का relationship क्या होता है? E V naught is equal to K max, where V naught is the stopping potential. ठीक है, यही relationship होता है. So what will be our answer? Our answer is going to be 0.55 electron volt. Is this clear? सौरभ बोल रहा है मुझसे सॉल्व नहीं हुआ, पता नहीं क्यों सर। कोई बात नहीं सौरभ, अगर सॉल्व नहीं हुआ तो सोल्यूशन मैंने एक्सप्लेन किया है, आप समझो, आप कॉन्सेप्ट को समझो। ठीक है, अब आगे जो क्वेश्चंस आएगा उसको ट्राई करना है। ठीक है, अगर सब आप सॉल्व कर ही देते तो इस सेशन का फायदा क्या होता? राइट, सब आप सॉल्व कर ही देते, विच मीन्स यू ऑलरेडी न्यू समथिंग. But if you are not able to solve something, or you are finding a better way to solve something, or you are getting your concept cleared, तभी तो फायदा हो रहा है ना इस सेशन का. So it is a positive thing. हिमांशु पूछ रहा है सर व्हाट डज द नेगेटिव साइन सिग्निफाई? लाइक ये दोस्त, ये हाइड्रोजन एटम का एनर्जी लेवल्स है. बोर्स मॉडल याद है, हाइड्रोजन एटम्स का एनर्जी लेवल्स है. n इज इक्वल टू 1 का -13.6 होता है, n इज इक्वल टू 2 का -3.4 होता है, n इज इक्वल 3 का -1.51 होता है. तो आपने अगर if you have confusion in this, so go back, you can find my session on Bohr's model. Okay, JEE Advanced 2022 session on Bohr's model. So you can go back and check that out. All right. Yes, guys, now we have arrived at the answer. So the correct option is going to be 0.55 volt. Is this correct? Clear? Any problem? Again, I am emphasizing on this fact that in this question also, क्या किया? बोर्स मॉडल के साथ मिक्स कर दिया, फोटो इलेक्ट्रिक इफेक्ट को बोर्स मॉडल के साथ मिक्स कर दिया. तो बोर्स मॉडल जब भी बात आ रही है तो अगर आपको एनर्जी लेवल्स याद है हाइड्रोजन एटम के, तो इट इज गोइंग टू मेक योर लाइफ सिंपलर, इट इज गोइंग टू मेक योर कैलकुलेशन सिंपलर. क्योंकि अगर आप स्टार्ट करते, अगर आप इसमें रिडबर्ग फॉर्मूला लगाने की कोशिश करते तो कैलकुलेशन लंबा हो जाता. ठीक है, जिन्होंने भी रिडबर्ग फॉर्मूला लगाया होगा कैलकुलेशन लंबा हो गया होगा। ठीक है, यहां पे मुझे कुछ नहीं करना पड़ा, मुझे सिर्फ ये करना पड़ा कि मुझे देखना पड़ा कि किसको सब्ट्रैक्ट करके ये रेंज आ रहा है, दैट्स इट, बिकॉज आई रिमेंबर द हाइड्रोजन का एनर्जी लेवल्स। तो मुझे सिर्फ सब्ट्रैक्शन करना पड़ा, मुझे आर जेड स्क्वायर इंटू 1/n² माइनस 1/m² वो सब नहीं करना पड़ा। हेंस आई एम टेलिंग यू इट इज वेरी इंपॉर्टेंट टू रिमेंबर हाइड्रोजन का एनर्जी लेवल्स। इफ यू डू दैट इट इज गोइंग टू बी वेरी हेल्पफुल। ऑलराइट, चलो ये क्वेश्चन हो गया क्लियर। तो बढ़ते हैं अब हम नेक्स्ट क्वेश्चन पे। ठीक है, चलो गेट रेडी फॉर दिस क्वेश्चन, दिस इज एन एब्सोल्युटली वंडरफुल क्वेश्चन, गेट रेडी फॉर दिस क्वेश्चन। A point source of light of power 3.2 milliwatt emits monochromatic light of photons of energy 5 electron volt. ठीक है? The source is located at 0.8 meter from the center of a metallic sphere of work function 3 electron volt and radius 8 into 10 to the power minus 3 meter. The efficiency of photoelectric effect emission is 1 for every 10 to the power 6 photons incident on the sphere. Assume all ejected electrons are instantly swept away. Find the time after which emission stops. अनुष पूछ रहा है, सर इज दिस द लास्ट क्वेश्चन? टाइम पे डिपेंड करता है अनुष, विल सी, अगर टाइम है तो और क्वेश्चन करेंगे। ठीक है, वी हैव टाइम राइट नाउ, वी हैव टाइम, डोंट वरी। आई थिंक इसके बाद हम एक क्वेश्चन और कर सकते हैं, बट दिस क्वेश्चन इज गोइंग टू टेक सम टाइम, दिस इज एन एक्सीलेंट क्वेश्चन। नाउ गाइज, डू यू अंडरस्टैंड द क्वेश्चन? रीड द क्वेश्चन अगेन एंड टेल मी, डू यू अंडरस्टैंड दिस क्वेश्चन? ठीक है, सो देयर इज अ पॉइंट सोर्स, इस पॉइंट सोर्स से देयर इज अ स्फीयर, देयर इज अ मेटालिक स्फीयर। ठीक है, सो रेडिएशन वुड बी एमिटेड. So we know that the emission, in the emission the photon has energy 5 electron volt and the power of radiation is 3.2 milliwatt. ये radiation के बारे में दिया हुआ है. ठीक है, now radiation is going to fall on it. So if radiation is falling on it, photoelectric effect is going to take place, electron is going to get emitted. Now we have also been given the efficiency, मतलब 10 to the power 6 photon गिरता है तो एक इलेक्ट्रॉन निकलता है. If 10 to the power 6 photons are incident, only one electron is getting emitted. ठीक है. Now the key in this question is this statement. Assume all this one. This statement. Find the time after which emission stops. ये समझने की कोशिश करना पड़ेगा. So guys, tell me, how would the emission stop? Can you explain that to me? When and how will the emission stop? Why should the emission stop? That is the question over here. If you are able to figure that out, then it's easy to solve this question. This is the key catch in the question. ठीक है, और भी key catch है इस question में, but this is the catch in the question, that why does the emission stop? It's a sphere. Radiation is falling. ठीक है, एनर्जी तो इसको मिल रही है, फोटो इलेक्ट्रिक इफेक्ट हो रहा है, लेकिन फोटो इलेक्ट्रिक इफेक्ट स्टॉप हो जाता है. व्हाई? द क्वेश्चन इज व्हाई डज द फोटो इलेक्ट्रिक इफेक्ट स्टॉप? दैट इज व्हाट वी नीड टू फाइंड द आंसर फॉर. दैट इज द कॉन्सेप्ट. टेल मी. Backspace is asking, electron on sphere is all knocked out. Electron on sphere is all knocked out. See, how many electrons are there on a sphere? Mole concept पढ़ा है, ठीक है? You have studied mole concept. So just imagine that on a sphere, how many electrons would be there? Think about it. Is it possible to knock out so many electrons? Is it possible to knock out all the electrons? So before we knock out all the electrons, something else is going to happen. Okay, think about that. Backspace, think about it. Sharat is saying acquires positive potential. हाँ, ये हुई ना बात. Sharat, excellent answer, lovely answer. Acquires positive potential. जी, तो पहले इसको समझते हैं. ठीक है, let's try to understand this. Now we have a sphere. Let's say कि इसका radius है r. ठीक है, we have a sphere. It has a radius r. Now light or photons are falling on it, which have energy 5 electron volt. So I'm writing it as EP. energy of the photon which is incident. How much is it? It is 5 electron volt. Okay, now what is going to happen? इसका work function भी दिया हुआ है. The work function is 3 electron volt. Okay, so electron is going to get emitted. ठीक है, and what is electron? Electron is negatively charged. Do you understand? Electron is negatively charged. So electron is getting emitted. As electron is getting emitted, that electron is taken away. ठीक है, it is instantly swept away. So electron is taken away. Now if the electron is being ejected, what is happening to this metal? Is it going to acquire positive charge? Is this going to acquire positive charge? Absolutely. If electron is getting away, electron is getting ejected, in that case this metal sphere is going to have positive charge. Now because of this positive charge, okay, let's say because of this positive charge, this gets a potential of Vs. Okay, this sphere gets a potential of Vs. Now any electron which now wants to get ejected, how much energy would it have? It will have an energy of minus EVs. ठीक है, another electron after this, after it has got a potential of Vs, any next electron will have an energy of how much? The charge on it is minus E, so it will have an energy of minus EVs. Is that correct? Now if I have to detach it from the metal, then I have to give this extra energy. Is that correct? Before, what was the energy that I had to give it? I only had to give it 3 electron volt. Okay, I only had to give it 3 electron volt, but now I have to give it an extra energy of EVs. ठीक है, क्योंकि माइनस EVs उसकी एनर्जी है, उस एनर्जी को जीरो करना है तो कितनी पॉजिटिव एनर्जी देनी पड़ेगी? EVs पॉजिटिव एनर्जी देनी पड़ेगी. आ रही बात समझ में? ठीक है, बट एनर्जी का सोर्स क्या है? एनर्जी का सोर्स तो सिर्फ ये EP है. The source of energy is only EP. So now what can I say? That EP is the source of energy. Okay, this is the only source of energy, EP. How much is already taken? The work function is the attraction from the nucleus. Okay, that is non-negotiable. So 3 volt electron volt is already taken. 3 electron volt work function is already taken from it. बचा कितना? 2 electron volt बचा. ठीक है, so how much energy do we need to supply it? We need to supply it 2 electron volt of energy to get it detached from the metal. ठीक है, so this is going to become plus EVs. Is that correct? आ रही बात समझ में? ठीक है, now after this what will happen? After this you don't have sufficient energy in the photon to give it the required energy. Okay, so what can I say from here? I can say from here that EVs is going to be how much? It is going to be 5 electron volt minus 3 electron volt, which is 2 electron volt. So this E and this E gets cancelled. So Vs is equal to 2 volt. Is this correct? Is this absolutely clear? ठीक है, which means that when the sphere acquires an energy of 2 volt, after that the photoelectric emission is going to stop. इसके पास कितनी एनर्जी है? 5 इलेक्ट्रॉन वोल्ट एनर्जी है. 5 इलेक्ट्रॉन वोल्ट एनर्जी में से 3 इलेक्ट्रॉन वोल्ट तो वर्क फंक्शन ले गया. ठीक है, बची कितनी? 2 इलेक्ट्रॉन वोल्ट एनर्जी बची. अब अगर इलेक्ट्रॉन की एनर्जी -2 इलेक्ट्रॉन वोल्ट है तो ये 2 इलेक्ट्रॉन वोल्ट उसको देके डिटैच कर देगा. बट अगर उस इलेक्ट्रॉन की एनर्जी -2 इलेक्ट्रॉन वोल्ट से और भी कम हो गई तब एनर्जी है ही नहीं, उसको डिटैच करने के लिए एनर्जी है ही नहीं. तो इसका मतलब क्या है कि फोटो इलेक्ट्रिक एमिशन वहां पे रुक जाएगा. इज दैट करेक्ट? सो व्हेन विल द फोटो एमिशन स्टॉप? द फोटो एमिशन विल स्टॉप व्हेन द स्फीयर अक्वायर्स अ पोटेंशियल ऑफ 2 वोल्ट. ठीक है, एंड व्हाट इज द पोटेंशियल ऑफ अ स्फीयर? ठीक है, दिस इज अ मेटल, तो सारा जो चार्ज होगा वो सरफेस पे होगा, विच मीन्स Vs वुड बी इक्वल टू व्हाट? Vs वुड बी इक्वल टू K Q divided by R. Now what will be Q in this case? ठीक है, so हाँ, let's say n electrons are emitted. ठीक है, I'm writing it as capital N. Capital N electrons are emitted, which means the charge is going to be Ne. The positive charge on the metal is going to be Ne. So this is going to become Kne divided by R. ये अपना आ गया equation number 1. Is this correct? So what I have figured out is that how many electrons get ejected. So from this equation, what can I figure out? How many electrons get ejected, after which the photoelectric effect stops. Is this correct? This was hurdle number 1. Clear? So Vs is equal to Kne divided by R. Is this clear? Is this absolutely clear? Anyone, any confusion? If this is clear, give me a thumbs up. Give me a yes. If this is absolutely clear. And ये जो कॉन्सेप्ट है ये कई जगह यूज होता है, कई क्वेश्चन में इसका यूज आता है. ठीक है, प्रीवियसली भी इसके ऊपर क्वेश्चंस इस कॉन्सेप्ट के ऊपर आ चुके हैं. ठीक है, सो गाइस, इफ दिस इज क्लियर, क्विकली गिव मी अ थम्स अप सो दैट आई नो दैट यू हैव अंडरस्टूड दिस कंप्लीटली. ठीक है, चलो अब ये तो हो गया. अब क्या निकालना पड़ेगा? नाउ वी नीड टू फिगर आउट that how many photons are falling over here, how many photons are falling on this surface. Okay, for that, what have I been given? I know what is the power, I know what is the energy of each photon. Okay, so how many photons are getting emitted per second? Can you tell me how many photons are getting emitted per second? The power divided by the energy of each photon. है कि नहीं? Is this clear? Power क्या है? Energy per unit time divided by क्या? Divided by energy. So what is that going to give me? That is going to give me the number of photons emitted per second. So this is going to be the power. This is what? This is power. And what is this? This is the energy of the photon. Correct? So what is N? N is power divided by the energy of the photon. Is this correct? So this is the N number of photons emitted per second by the source. But this is what? This is a point source. तो ये जो point source है, this is emitting photons in what direction? It is emitting photons in all directions. Like if this is the point source, it is emitting photons in all directions, all possible directions, which means it is going to emit photons in a sphere. Is that correct? So what we need to understand is that we need to build a sphere like this. So this N is the energy, is the number of photons per second. Gaurav, 360 degree नहीं, नहीं, ये sphere की बात हो रही है. हर direction में, इधर, 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 हर direction में, radially outwards. So these number of photons per second are getting emitted in what surface area? Let's say this is R. Let's say this is capital R. The distance between the point source and the sphere is given. How much is that? That is 0.8. ठीक है? So it is getting emitted in what surface area? मैं show भी कर रहा हूं. What is this surface area? What am I showing? So this number of photons per second is getting emitted in what surface area? It is getting emitted in 4 pi r square surface area. ठीक है, पूरे स्फीयर में होगा ना, पूरे स्फीयर में इसका इन्फ्लुएंस होगा. आ रही बात समझ में? So this is the number of photons getting emitted per second, and in what area it is getting emitted in 4 pi r square. ठीक है, तो अब मैं क्या बोल रहा हूं कि what I'm going to do is I'm going to divide it by 4 pi r square. Is that correct? Which means that per unit surface area, how many photons are getting emitted per second? Do you get this? Per unit surface area, how many photons are getting emitted per second? Is that correct? यहाँ तक clear है? Okay. Now are all these photons reaching this sphere? ठीक है, photon तो यहाँ पे भी जा रहा है, photon तो यहाँ पे भी जा रहा है. Are all these photons reaching this sphere? No, all the photons are not reaching this sphere. Where are those reaching? Here. So how many photons would be there which would be reaching this sphere? Which would be in this surface area. Do you get this? Which would be in this surface area. What surface area? This surface area is lying on the bigger surface area. ठीक है? So what will be this surface area? ठीक है? What will be this surface area? Is it going to be 2 pi r square or pi r square? Guys, quickly tell me. तो जो सरफेस का ये वाला साइड है, जो स्फीयर का उल्टा साइड है, उधर तो रेडिएशन पहुंचेगा ही नहीं। रेडिएशन किधर पहुंचेगा? रेडिएशन इधर पहुंचेगा। नाउ आई वांट टू नो फ्रॉम यू दैट ये 2 पाई आर स्क्वायर होना चाहिए या पाई आर स्क्वायर होना चाहिए? थिंक अबाउट इट एंड टेल मी। ये जो स्फीयर है, ये जो स्फीयर है, इसका हेमिस्फीयर का एरिया कितना होगा? इसके हेमिस्फीयर का एरिया 2 पाई आर स्क्वायर होगा, ठीक है। बट व्हाट शुड आई यूज ओवर हियर? शुड आई यूज पाई आर स्क्वायर और शुड आई यूज 2 पाई आर स्क्वायर? कुछ लोग बोल रहे हैं 2 पाई आर स्क्वायर, कुछ लोग बोल रहे हैं पाई आर स्क्वायर, ठीक है। लिसन टू दिस वेरी केयरफुली। दिस इज गोइंग टू बी पाई आर स्क्वायर, ठीक है। नाउ अंडरस्टैंड दिस, नाउ अंडरस्टैंड दिस दैट द सरफेस एरिया वी हैव टेकन, ठीक है, द सरफेस एरिया वी हैव टेकन इज दिस वन, ठीक है। जो सरफेस एरिया वी हैव टेकन इज दिस वन, ठीक है। So all the photons that are going to fall on this surface, all the photons that are going to fall on this surface would have fallen on this surface. ये बात समझ में आ रही है? समझो इस चीज को. This is another catch. All the photons which would have fallen on the blue surface are going to fall on the green surface. ये बात समझ में आ रही है? ठीक है. But number of photons per unit area, which area have we taken? Have we taken the blue area or have we taken the green area? The green area is part of this area. ठीक है. ये जो sphere की हम बात कर रहे थे, the green area is part of that sphere. Correct? So all the photons that would have fallen on the blue area are going to fall on the green area, but green area is part of the bigger sphere, is part of that 4 pi r square, which means what we have done is n divided by the total surface area, and we'll have to multiply it by which surface area? We'll have to multiply it by the green surface area. In other words, what we'll have to do is we'll have to take the projection of the blue surface area. Is that correct? We'll have to take the projection of the blue surface area. तो अगर ये हेमिस्फीयर है तो इसका प्रोजेक्शन क्या होगा? इसका प्रोजेक्शन, इसका शैडो क्या बनेगा? इसका शैडो एक सर्कल बनेगा. ठीक है. उस सर्कल का एरिया कितना होगा? उस सर्कल का एरिया हो जाएगा पाई आर स्क्वायर. सो हियर आई विल मल्टीप्लाई इट बाई पाई आर स्क्वायर. इज दैट करेक्ट? ठीक है. सो P अपॉन EP was the number of photons emitted. The number of photons emitted in that entire big sphere. ठीक है. So number of photons emitted per unit area was divided by 4 pi r square, and what will be the number of photons reaching this sphere? It will be multiplied by pi r square. Is that correct? So what have we figured out? What is this n? Number of photons per second falling on the sphere. Is this correct or not? ठीक है. If this is clear guys, this was another catch in this question. ये 2 pi r square और pi r square का जो चक्कर था, this was another catch in the question. So if you have understood this, give me a thumbs up so that I know that you have understood this clearly. Is this clear? Yes sir. Gaurav is saying yes sir, done. All right, very good. So you understand that how did we work out that it will be pi r square and not 2 pi r square. Okay. So what is this? What is this we have calculated? The number of photons falling per second on the sphere. So यहाँ से ये pi और ये pi cancel हो जाएगा. So this is going to be n is equal to P upon EP into r square divided by capital R square into 4. Okay. But our job is not done. Okay, so this is only the number of photons which are falling, but number of electrons कितना eject होगा? ठीक है. Number of electrons कितना eject होगा? How many number of electrons are going to get ejected? For 10 to the power 6 photons, 1 electron is going to get ejected. So can I say that the number of electrons getting ejected per second will be equal to P upon EP r square upon 4 r square. ठीक है. So number of photons So for 10 to the power 6 photons, one electron is getting ejected. ठीक है? So the number of electrons that are going to be ejected would be the number of photons which are being ejected per second divided by 10 to the power 6. Is that correct? So this would be the number of electrons which are going to get ejected. Is this clear? ठीक है? So in how much time? Now what is the thing? That NE is the number of electrons ejected per second. This multiplied by T should be equal to what? It should be equal to the total number of electrons ejected from the metal. ठीक है? This N we had already calculated. So let's go back and check. This capital N we had already calculated. This one, this equation 1. ठीक है? This equation 1 से capital N we had already calculated that what is the total number of electrons that should be emitted. Correct? So Vs is equal to K Ne by R. We are going to use that as well. Vs is equal to K Ne divided by small r. Alright. Now everything clear? ठीक है? So number of electrons ejected per second multiplied by the time should be equal to the total number of electrons ejected. So now all we have to do is we have to do the substitution. So T will be equal to capital N divided by Ne. What is capital N? Capital N is VSR divided by KE. And what is Ne? So we have to divide it by Ne. So this is going to become PR square, and then in numerator we'll have EP into 4R square multiplied by 10 to the power 6. ठीक है? अब यहाँ पे calculation भी इतना मुश्किल नहीं है. The calculation is not that difficult. ठीक है? So Vs is how much? Vs we already thought had calculated was 2 volt. What is the value of R? R is given as 8 into 10 to the power minus 3. ठीक है? By the way, this R and this R square gets cancelled. What is EP? EP is 5 electron volt. So this is 4. What is capital R? Capital R is, what was capital R? 0.8 square. And then we have 10 to the power 6 divided by the value of K will be 9 into 10 to the power 9. E I am leaving as it is. ठीक है? P कितना था? P was 3.2 milliwatt. So 3.2 into 10 to the power minus 3 watt. And then we have to substitute the value of R. The value of R was how much? The value of R was how much? 8 into 10 to the power minus 3 meter. ठीक है? Now you see here is 5 electron volt and here is the electronic charge. So E and E gets cancelled. So all of this we are going to get in what? We are going to get in SI units. तो इतना मुश्किल calculation भी नहीं है. We can like handle this calculation. ठीक है? ये 2 4 से 8 चला जाएगा. 0.64 है, नीचे 3.2 है. तो वो सब कैंसिल हो जाएगा. So finally the answer comes out to be approximately 111 second. Is that correct? All right. Is this clear? Guys, if this is clear, quickly give me a thumbs up, give me a yes. This was a fantastic question. ठीक है? I'll summarize this question. This was a fantastic question and it had 2 major roadblocks. ठीक है? So I can summarize this question for you. No problem at all. The first thing was, why will the photo emission stop? ठीक है? Why will the photo emission stop? So what did we understand here? As electrons are getting emitted, the sphere is attaining positive potential. Now because of that positive potential, it is going to pull the electron. There will be an extra pull on the electron. ठीक है? Okay. How much would be the pull on the electron? What will be the energy of the electron? The energy of the electron would be minus EVS because charge on electron is minus E. Now if I have to free this electron, how much energy should I give it? I should give it positive EVS. Correct? ठीक है? Okay. Now the source of energy is only EP. The photon which is falling, the source of energy is only EP. उससे ज़्यादा energy नहीं मिलेगी. So this energy should overcome the work function also, and this energy should overcome the attraction on the electron due to the positive charge also. So EP should be equal to 5 plus EVS. So from there we calculated that when the shell achieves a potential of 2 volt, it is going to have, the photo emission is going to stop. Okay, when the shell achieves a potential of 2 volt, the photo emission is going to stop. Correct? So वहां से what did we get? We got Vs is equal to kne upon r, एक shell का potential. Correct? N is the number of electrons which got emitted. So यहां से हमें क्या मिल गया? यहां से हमें capital N मिल गया, meaning the number of electrons that got emitted. What was the next problem? The next problem was to find out how many photons are falling on this sphere. ठीक है? How many photons were falling on this sphere? So how did we calculate that? So P upon EP are the number of photons emitted per second. But this emission is happening in the entire surface area, in the entire spherical surface area. So per unit of that surface area, what is the emission? Divided by 4 pi r square. Okay? But what is the area of the sphere? The area of the sphere is going to be pi r square. The area of the sphere on which, the metal sphere, on which the radiation is falling, we are going to take it as pi r square, because pi r square is lying on that big area, on that large surface area, not 2 pi r square. So basically we'll have to take a projection of this 2 pi r square. Is that correct? Okay? So from there, what did we calculate? We calculated the value of N, okay? And then finally what did we do? We found out how many electrons are emitted per second. So number of electrons emitted per second into time will be equal to the total number of electrons which are emitted. After doing the calculation, we got the answer as 111 second. Okay, guys, is that clear? Is that absolutely clear? ठीक है? So if that is clear, ये question करके मजा आया, इस session में मजा आया, you thought you extracted something out of it, then give me a thumbs up, give me a yes, and do like this session as well. That will mean a lot to me. Alright guys, so I'll have to end this session right now because there's a little bit of time crunch. Please write down your questions in the comment section and I'll try to answer all your questions. Okay? Put all the questions in the comment section, not in the live chat, in the comment section. I'll check and I'll answer that. Okay? I'll try to answer all your questions. Alright guys, thank you so much for attending such a session. Maza aaya, okay? Hopefully you enjoyed it as well. So we are going to meet very soon on Wednesday. Next Wednesday मिलेंगे and I am going to bring thermodynamics. Alright? चलो. तो फिर मिलते हैं next session में. तब तक के लिए keep practicing, keep getting better and have fun with learning and all the best for JEE Advanced 2022. See you.